Cool. So I'm Becky Stewart. I'm a lecturer here at Queen Mary, and I my research field is in spatial audio and have been working a lot with the Bela team lately. I will go in a little bit more detail as to what a Bela is, though you now, I think, all have a Bela connected to your computers. And so today we're going to be combining the two of doing some spatial audio, some binaural audio rendering with the Bela board. So just a couple kind of disclaimers for the day. I am not the person in the room who knows the most about Bela, I don't think. So please ask each other and ask multiple people questions. Certainly ask me questions, but we also have Robbie here to help out as well. I'm probably not the person in the room that knows the most about pure data programming either. I would be very quick to not say that I have any huge confidence in working in pure data. Very easily someone else who has really done anything much with it is probably better than me. So please also ask each other, and if you see something in which you say, hey, I think it'd be better if you did something like this in pure data, then please also pass that along and let us know as well, because it's not so much of the I don't do a lot of it in day-to-day. And then, yeah, so if any of these things are totally new to you, that's totally fine and not a problem in the slightest. That's what we're here to learn. So please ask questions. Ask questions of each other, ask questions of me, ask questions of Robbie, and we will all make this an interactive, not a kind of university lecture session. Is certainly not the aim here today. So what are we going to do today? We are going to, I realize I wore my squeaky shoes on this floor, these shoes. So I'm sorry, we're all going to listen to that all day. So we're going to do a brief intro to programming with pure data. Which way do I want to ask the question? Who has never done anything with pure data before, completely new? Excellent. Who feels like they've done, if I told you to kind of open up pure data, make a patch, and have it play back a sound file, feels like they have that level of competency in pure data? Okay. And everyone else has kind of maybe done something with it but doesn't feel that confident? Is that kind of the right kind of play for the room? Okay. So we're going to start kind of from zero in this kind of accelerated intro to pure data. I'm hoping it won't be too boring for those of you who already have worked with the language a bit more, and hopefully will be enough to get those of you who are new to it a bit up to speed to be able to interact with it inside of Bela. Then we'll move on. So we're going to start with just doing pure data on the computer and just working with it there. Then we're going to move over to working with Bela and how we use pure data in order to program Bela. And then we'll start breaking out the spatial audio. And so we'll talk a little bit about some spatial audio theory and then be implementing some of that theory. Not so much implementing, interacting with libraries that are implementing that theory. We don't have that much time today. In 3 hours, you're not implementing from scratch spatial audio at all. You'll be interacting with some libraries on the Bela. So that's our general plan. So any questions at this point? We good? Cool. So some basics first. So we're going to be working with PD vanilla, not PD extended. So if you've worked with, I just realized I'm completely out of the view of the camera, need to remember. Am I okay here? Yeah. So for pure data is an open source graphical programming language. So if you've worked with Max before, it's like working with Max if Max was like a toddler. So it's a really kind of stunted version of Max. The UI holds up the reputation of open source software really well. That's not a compliment. And so we're working with PD Vanilla in particular. So PD Vanilla is the core pure data library application. PD Extended is then additional kind of user-contributed objects and functionality. And so Bela can only work with things that exist inside of PD Vanilla. So that's why we're working with PD Vanilla. So if you've worked with PD, you've probably worked with PD Extended. And so we're going to be stepping back and only working with the vanilla. And again, that's because that's what Bela can handle, which is related to libpd for those who understand what that even means. So all of the content for what we're doing today is up on a wiki. So if you go to bit.ly/Soundstack2018, there you will have, and this will continue to live after the workshop, all of the code that we're working with today is up online, open source in GitHub projects already. So you can go and continue with it as you will afterwards. And then all the additional kind of documentation for the workshop as well is up there. So you can not feel like you need to take too copious of notes, and that you have a bit of help for you up there already. So that's bit.ly/Soundstack2018. So let's start by, going what do I have for Windows? Let's start by going there. Oh, I totally forgot about the Wi-Fi. Yes, sorry. So I can get that out of my email as well. Sorry. So if you're a guest, if you're not at QM, move over to the screen. Sorry, we set up a guest Wi-Fi that you can access. Why? Come on. Totally forgot. So if you just have EduRoam credentials from anything else, you can use EduRoam. Let me find where they emailed me the guest access. So the Wi-Fi is, you go to QM events, I believe. Is that correct, Angela? Yeah. So you go to QM events for the Wi-Fi network, and then it's this very catchy series of letters and numbers is the Wi-Fi password for anyone who does not have EduRoam credentials. So that's capital BRI, capital N2833. It should be events, I believe. Hopefully it's set up correctly. Is that working? Yeah, good. So we're a little bit at the mercy of the IT people actually doing that. Okay. So we are hopefully looking here. So here's the wiki for everything that we're doing today, including the PDF to all the slides as well are accessible. So that's there. What we're going to do is going to be doing a bit with pure data. So does anyone need to install PD Vanilla, or does everyone have PD Vanilla on their machines already? Who needs to install? It should be vanilla. Let me see if there's, is it in the name? Does it say? Yeah, I think that is true. So you should be able to open up an application that looks like this. I don't know if 0.48 is the most recent or not. It's the one I have. But we open pure data. You can go away. So when we open up pure data, we get something that looks like this. So we have, oh, you can't quite see it at the top. This window is just where things get printed to us. So we don't interact with this window at all. This is just the message printing window. When we want to actually code something new, we go to New, and we create a new patcher. And so now, in that way, everyone loves to have their own little name for things, like an Arduino sketch or a processing sketch. We have a max patch or a pure data patch. And so a window that looks like this that doesn't have this kind of top bar on it, this is now a window that we can interact with and actually create our program inside of. So to create a program, we don't type out things here. We're not writing text. We're going to be working with blocks. And so we have why have you gone funny? There we go. Okay. So if we go up to put, we can see a list of different things that we can kind of bring in and put here. So we're going to first work with object. So when we do put and then object in the menu, we have our little hand cursor, and we have our dotted blue box with a blinking cursor following us around. So we click somewhere, and the box drops there. So that's a click just to drop the box somewhere. We have a cursor, and in here we print what is the thing that we want to have happen. So this is from a known library of things, and so print is one of the things from the library. So we type in print, and then we click somewhere else outside the box in order to say we're done. So we now have a box that looks like this. We can drag it around if we want. If you make a typo, you can click on it and edit it. So let's say I had a typo and I accidentally left out the N. I have this dotted line, and I have an error message now because it doesn't know what prit is. But if I click and put back in the N, it turns into a solid box, and we have this other little kind of square in the corner, and we don't have any new messages. So the old message is still there, which can be confusing, but it's now no new ones are made. So we've correctly said the name of a function of an object that Pure Data Vanilla knows about. So, and it's print, and we can probably guess what it does. Hopefully, it just does what it says. So let's give it something to print. Let's go up to put and message. And, oh, I clicked. And somewhere above that print, we're going to drop our little box. We notice the very subtle cues of it's curved on one side, making it which is what kind of labels it as being a message box instead of an object box. And we're going to type in whatever message you'd like, a single word. If you start putting spaces in, it thinks it's thinking it's a more complicated data object than it is. So just a single word. So we have a message, hello. We have a function of print. Now I want to send hello to print. So I take and hover on the bottom little box coming out. So in PD, like in Max, we're going to think about programmatic flow is something starts at the top, and then PD is going to go from top to down. So things that are from here, we want to connect to here. We hover, we have a circle. We drag and connect to the print. So I'm doing a drag and then a release when I get above the other print to make the patch cord between the two. So now I have the potential of a program where when I tell it to, hello will be sent to print. So in order to actually make that happen, I need to move out of this edit mode and go into what's called run mode. A couple ways you can do this. You will very quickly learn the keyboard shortcut. So on Mac, it's the Apple E, and then Control E on Windows and other Linux flavors. And we're going to go to Edit, and then we want to untick Edit mode, and we also see what the shortcut is there. So we just want to go out of Edit mode. We know we're not in Edit mode only because our cursor has changed. So we no longer have a finger, we now have an arrow. So when we're in edit mode, and also again, beautiful UI, UX experience here, I'm in edit mode now, but I haven't moved the mouse yet, so you don't know that you're in edit mode. You move the mouse, and then you see you're in edit mode. I'm now out of edit mode and run mode, but not until I move the mouse do you see that's happened. So this is the user experience you will come to expect from PD. It's a good price for the product, though. So we are going to be in run mode, so arrow, And now I can't edit things anymore. So I can't click on print and change it. However, message now becomes an interactive element. So message itself, a message box, turns into a button. So I can click on it, and it acts like a push button. So I click on hello, and we have a little print message of hello. So we have our message. We have our patch cord going to our object, and our object is the action. It's the thing that's doing something. Does that make sense so far? Cool, because now we're going to kind of step it up. So that's the kind of just really basics of interactions here. And now we're going to work with a bunch of pre-made examples to get us going a little bit faster, because you don't need to sit and come up from scratch with a bunch of functionality in Pure Data. We're going to build on functionality that exists and just work with those patches first. So if we go to oh, here we go, sorry, number 2 in the list. So here we're going to go, you click on there, and that should take you to, it should start downloading a zip file. And in that zip file is a bunch of Pure Data patches and some audio files as well. So clicking on that should, if I put it all, yes, excellent. So it should be puredata-bela. I think examples .zip. Where am I? And then so put that wherever you want. It doesn't matter. Wherever you want to put it in your own system is fine. Sorry, let me put this up. So for me, it's Pure Data. There you are. Pure Data tutorials. So we're going to take a look. We're going to work from this folder called examples. So the way we're going to kind of move through for the next, I don't know, maybe hour or so, is we're just going to work our way through these examples. The first 4 of these examples, we're just going to look at on our computers and interact with on our computers. And then from example 5 through 8, we'll be moving on to the Belas. So just so you have kind of an idea of how we're doing this today. So let's start with playing an audio file in PD. So you're going to open this. It will give you errors. Sit with that and be okay with the errors. Don't freak out. Just know you're going to open it, and PD is going to complain at you about it. It's not going to complain at me because I've made the fix, but it's going to complain at you. So you should open it, and it will not look like this. It should look similar to this, but not exactly this. Has everyone gotten the downloads to work okay? Yeah, so it's off of that Soundstack. So if you, oh, sorry, so it's bit.ly. So bit.ly. /Soundstack, all lowercase, 2018. Yeah, then /Soundstack2018. Yeah, and so then under the section Intro to Pure Data, number 2 is the download link. Okay, so then that should download a zip. Yeah, looks like cool. Anyone else having difficulties getting to the examples? You're okay? Okay. So when we open up the one called _main.pd under in folder 1, so playing an audio file in PD, you will not have exactly the same experience as me. So just to emphasize, that's what we are looking at. So when you open up yours, play audio file should have those dotted lines. there should be, output should have those dotted lines, not look solid, and you should have some errors over here saying couldn't create play audio file, couldn't create output. Correct? Is that everyone's experience? Excellent. So that's because play audio file and output are both things that we've written. Andrea here at Queen Mary in particular has written. And so we need to tell PD where to find those. So those are also in the files that the zip file that we downloaded. So it's actually just all sitting inside of the folder abstractions in that zip file. So we just need to tell PD. So for example, we can go and look in the list and say output.pd. Ah, there's output.pd. Now we just need to have PD actually know where this folder is and tell it to look for other things in that folder. So back inside of PD, we're going to go to File if you're, sorry, PD. So if you're on a Mac, you're clicking on PD and then going to Preferences and then Path. If I clicked on that too soon. Sorry. Preferences and then Path. If you're on a non-Mac operating system, I think it's File then Preferences. I think is the way to get to that. And then that's going to open a window that looks like this. So, sorry for came in a little bit late. You're not with Queen Mary at all, right? No. Do you have edgy roam credentials, or do you need Wi-Fi access? Yeah, probably. Yeah, yeah, I can show you the Wi-Fi. Yeah, I can show you the. So if you go to QM events, is the Wi-Fi. Yeah. And yeah, perfect. Okay, so back over in Pure Data. So you're going to do what I've already done. So we have a list of paths here where it's just looking for other things that should be able to easily import into Pure Data. So you're just going to want to say New. It's going to open up a Finder window or Windows Explorer, depending on whether it's been named by Jobs or Gates. And then you're going to navigate to wherever the abstractions folder is that you've downloaded. So it's inside the zip folder that you downloaded, and then abstractions. So you just want to be, so like I've done that actually twice. This one can go away. So that's my path to my abstractions. So once you've done that, you hit OK. And then if I recall, I think you have to close PD, quit PD, and then reopen it and reopen the patch in order for it to go through that searching process and find the folder again. And so this time, when you quit everything and reopen, it should look like mine. So go ahead and do that. Oh, second question, while you're doing that, does anyone need headphones? We're going to then be playing some audio. That will be a bit overwhelming if everybody plays the audio at the same time. Plus, we're working with binaural, which kind of by definition, we'll need headphones. I have lots of headphones. Who needs a pair of headphones? One? That's it? Okay. Do you want to sit? You can sit at the table. Anyone else? Everyone else has headphones. Okay. Cool. Does anyone want me to pause still? Am I here to go on? Okay. So what's happening here is hopefully fairly self-explanatory. If not, we've not done a very good job writing the patch. So we have our play audio file down here. This is handling the playback of an audio file. We have output that handles the output to the headphones, to your audio sound card. There's a couple things we need to do in order to interact with this. So first, we need to initialize, we need to tell play audio file what sound file is going to be playing. So we click on vocal0.wav. So of course this is in run mode, not in edit mode. Then if we want to play it, we click on play. And we should then, these two guys are volumes. So we can play it, stop it, play it, stop it. We have our very cheap effect of, if you like as well, which is the pitch. So your first task, just to get a little bit comfortable with working with all of this, is go through and change out this WAV file to be something else. So if you want to go through just the ones we have, inside of the abstractions folder, it already knows where the abstractions folder is, so you can just give it the name. You don't have to give it the full path. So there's a whole bunch of things in there you can choose from. If you click on samples, there's just all of them together in one place if you just don't want to have it mixed up with all of the abstractions. So choose one at random, choose one that you like, choose one that you hate, if you want to hate listen, I guess, and swap it out and go through the steps so that you can play back the different audio file than what's already set up there. Probably. Yeah. Yeah. And I'm not sure if you put it in the, so if you put it in the abstractions folder, it probably won't, I don't know if it will know that it's there. You might have to relaunch, but if you want to avoid that, you can try and see. You also could avoid that entirely, and if you put it in the same folder as where the patch itself is, if you want to put in a new audio file that's completely not included here, if you put it in the same folder, it will automatically look for it being located in the same place as the PD patch that you're running. So yeah. So if you just want to use one of the ones already included, we'd go in here. So we edit mode, so we're finger pointing instead of arrows. Let's choose synth loop 5. Why not? QM events. So now, we want to reinitialize it, so we want to reload this in. So I click on it, make sure there's no errors there, which meant it could find the file. And then we say play. And that's synth loop 5. Okay. Questions, difficulties in changing out the audio file to be something else? It's always the problem with working with headphones, is then you have no idea if it's working out. So I'm trusting you to say if it's not working out. You need to tell me if it's not working out. Otherwise, I'll just assume we can move forward. Okay, so we're going to move past this one and now go on to example number 2, which is building on this one. So looking at example number 2, and now we are introducing a different type of playback. So immediately this might be like, why are we doing this? We have here a slider. This slider is going to go ahead and send that play signal to our play audio file only if this slider is above the threshold in the message box. So this, you may say, that's okay, sure we can do that. That seems kind of stupid, but I guess we can. So this is to set up how would we trigger something if we had a sensor input. So if you're thinking about working, because we're going to work with Bela, yes, Bela can just be a kind of cheaper computer to run some PD, but really its strengths come into play when you start having sensors and inputs from the physical world to control the audio as well. That's really what it's, it really sings at. And so this is just kind of stepping our way towards that. So we have our set threshold object here. And then we need to instantiate a couple things. So we need to set things up. So we click to say, OK, that's our threshold. Going to click to say that's going to be the file that we play. And then we interact with it in the same way. So we can increase this. Sorry. Put the volume up. So if we're below the threshold, we don't play. Above the threshold, we do play. So same there. So have a play. You can change out the audio file. You can change the threshold. So again, you do that by going into edit mode. And you can change what if you want it to be more sensitive, so it starts playing very quickly. You put it into 3. Remember to actually click on it to kind of load that number into set threshold. And now the volume up just above 0.3, and we have sound playing back. Off, sound playing back. So have a play with that. If you're already quite familiar with PD, and this is seeming super basic to you, all of these are, or you're just curious and want to learn more, all of these are abstractions, which means you can click on set threshold, and it will open up the source for you. So in kind of web terms, it's like saying view source. And you can see how it was put together kind of behind the scenes. If you don't care, if you are very happy interacting just with the Pure Data patch and you don't necessarily want to kind of be able to recreate it from scratch, you don't need to click on it. You can kind of let it be, let it be. But you can do that for all of the abstractions that we've written. So play audio file and output, if you just click on any of them, you will see all the details that we are very intentionally hiding from you. So if you don't care about these details, you do not have to deal with these details. We just have an object that plays back a file for you. If you would like to see everything we're doing for playing back that file, then you can open it up and see. And then kind of just keep going down the rabbit hole. So, yeah.
This box with the TBV, this conjunction with
yeah. That is triggering out 2 bangs. So it's listening whenever it gets a bang, or whenever something comes in, it's sending a bang out this outlet and another bang out there. So it would also, so actually also for any of them, if you right click on it, you can bring up a help and see more about it there as well. Actually more than me just talking. So yeah, so for any of the objects, if we wrote them, you click on them, a single click will open up a new window. If they're a PD object, so like this array here, we see this waveform, we right click on it, we bring up help, and then you can see more information about it as well. So you have all of that to kind of build off of. Because we're not going to be able to teach you all of the intricacies of Pure Data in, even just a morning. But there's the tools there for you to dig in further if you'd like to. So let's take a look now at number 3. So this should all hopefully feel quite incremental in what we're doing. So we're building on what we had before. So we have our threshold. We have the volume for the playback. We have our threshold. We set our threshold in the same way. We have to load in what the audio file is in the same way. But now we have a couple other things down here. So we have first an effect of reverb. And then we have, it's just called the hello effect. It's just, actually I don't even remember what it is. But it's just some other random effect that gets applied. And so if we want to set the threshold, load in an audio file. So if we do above the 6, so it's playing, we can then add in reverb. And then we can stop it. And so we have hello effects here. So you can have a play with those. And then we have 2 others down here that are prepared as well. So if you want to, you could swap out. So if you don't want reverb, you could do distortion a tilde instead, and everything should still be connected. Yep, and so then put it back in run mode, and you should have a distortion instead. So we have a couple pre-made effects for you to play to kind of that you can work with today. So you can have a play at those and interacting with those and plugging things together. And then if you interact with the reverb one, you have started working with spatial audio today. And I will give my mini rant on how reverb is the first spatial audio, even though that's not what people think about later.
That's not related to that, that's like a generic
you can connect to that.
Okay, so hopefully are those patches feeling kind of like you don't need to necessarily understand the nuts and bolts of how they're working, but you feel like you could kind of mess with them and get them to do a bit of what you want, hopefully. Questions over that? Let me highlight some of the weird things in here, particularly for those who are a little bit, actually doesn't matter if you're experienced with pure data or not. So let me highlight some of the weird things that we've kind of had to do to make this patch work. So we now have two audio files playing. So we have our play audio file here. We have our play audio files there. If you are experienced in PD, then what's happening here is there's an associated new array being created every time you create a new play audio file. So it does all that nicely in the background for you, so you don't have to worry about namespace clashes for that. That was some of Andrea's cleverness. And then we have, for each of them, we have what our file name is getting loaded in. We have the threshold setting, just outputting whether it's playing or if it's stopping. This thing here is hacky. I'm really sorry. It's really hacky as hell. So what I've done is output. At this point, you could mix the overall volume relationship between the two, or you might want to have a master volume as well. And so kind of the default way is for each sound file to have its own volume. In order to also add the functionality for it to have a master volume, this is then kind of the PD hacks that have happened to it. So we have here our master volume going in. Because the volume is normally, if you don't have this fader here, the volume will be just set to max, to 1. So what we have here is load bang, which we'll start seeing a lot of load bang soon. Load bang, what that does, it means as a bang is a message being sent through the pure data system. Max uses the same kinds of terminology. And so a bang just means a do this, just do thing function. And so load bang is a function that automatically sends a bang when you open up the patch. So we have like load bang over here is turning on, whenever we open up this patch, it automatically turns on the audio, for example. So kind of by default, when you open up PD, the audio is turned off and you explicitly have to turn it on. This does that for you, which you might have spotted in the corner of the previous 3 patches as well. So load bang here is saying, okay, don't listen to the default value that's programmed inside of this abstraction of output. Instead, listen to what the value is here. So it starts at 0. Then up here, the volume here is being sent in at, it can be from 0 up to 127. So 0 is going to be the sound is off, 127 is max. And that's related to MIDI. If you're like, why? That's a weird number. It's because of MIDI. And then it's one of the default sliders outputs 0 up to 127. So we're just kind of replacing a full slider with just the number box of that slider, that graphical element outputs. So the load bang here, the delay. The delay is a particular PD hack. Somewhere else there's a load bang in there where we're actually setting the volume of the audio file, I think to be 0. So when you first start it up, it doesn't all just start playing out really loud. So we're waiting for that to be set to 0, waiting 3 milliseconds, and then setting it to this new number. It is not elegant, but that is what's happening. Just if you're kind of trying to get your head around what are all these weird little things happening in here. And that's entirely because of trying to give a master volume. So that is the kind of hackiness of this. So that's interacting with PD. Any general questions about the PD side of things, because we're going to then move kind of from necessarily working directly with PD to now working with PD on the Bela. But anything before we move on?
Quick question, is
Yeah.
this patch in presentation mode, or is there presentation mode in PD?
No, PD doesn't. It has edit and run mode, but not a third presentation mode. Yeah.
I'm just wondering where all these background things run. How do I see that?
Oh, if you click on it, it will open up as an abstraction.
Ah, okay.
And so if you click on it, you can then see the
Ah,
abstraction
yeah.
underneath.
Okay.
Yeah, yeah. And then it still has help files like Max, just not as user-friendly. If you right-click on any one of the files, or on a native PD object, then you can open up a help for it as well. Yeah. But yeah, otherwise, so working with PD, oh, actually one other thing for PD that's useful to know. PD vanilla does not have that many objects. It has kind of mostly everything you would need in order to make just about anything. But unlike Max, which kind of, you don't have to do so much work yourself to put things together. If you want to just see, you can click on Help inside of PD and List of Objects. And here is every single object that is known to PD, which is useful. So it's useful in that there's not that many, so it's pretty easy to scan through and figure out what is it that you want to do. And then any one of these, you can right-click on, and open up the help file to see examples of how to use it, and so on. So that is as much help as you will get from pure data. So if you come from the Max world, this is nothing. Max does a lot more to help you out, but this is what you have in the PD world. I think that's everything kind of essential to get you going on PD. Again, I'm not anticipating even necessarily all of that being absorbed if you're completely new to PD. That's a lot to take on. So please ask for repeats and clarifications at any point in which you're like, wait a minute, PD doesn't do this thing. Especially if you're used to Max and you're like, wait a minute, this seems to suck. Why does that happen? Okay, what are we doing? We're back in the slides. Yeah. It's a toggle. So this is actually just a visual kind of thing. So this is a toggle switch. So you click on, so when you're in run mode, you can click on it, and that is an off switch. Click on it, it means it's on, and we can see, we should be able to, let's try to get both of these things. We should be able to see, this is the audio DSP, so that means audio is off, DSP is unclicked. If we click on it, it turns it on. So it's just to make it inside the same patch, that kind of thing. Yeah. Okay, so now we're going to move to working with Bela. So we have two different Belas spread around, which is kind of exciting. There's more than one Bela. So the first one, not the first one, the smaller of the two, looks like this guy. So this is a Bela Mini. It has almost all the same functionality as this Bela. So this is the Bela, I call it the Bela Classic. I don't know what Bela, this Bela. It needs something. It needs a disambiguator though. So the Bela Classic, the Bela Old School is this guy. And then this is our Bela Mini. So they do the same thing. There's one slight difference in which Bela Mini doesn't do analog outputs, but that doesn't have any bearing on what we're doing today. We're only going to be working with analog inputs, and both of the Belas have the same thing, have that capability. What Bela is, has anyone worked with Bela before? Who's worked with Bela before? Couple, Queen Mary, but largely no. Okay, cool. So who's worked with Arduino before? Hope all of my students at this point now have no, really? Oh, okay. So in Raspberry Pi type things? Fewer. Okay, so Bela is kind of like an in-between a Raspberry Pi and an Arduino. So an Arduino is a microcontroller. So it's a really, really simple computer. So it's what would run a lift, it would run a microwave, It's not something that you would use to check your email, for example. And a Raspberry Pi then is a full Linux computer. Actually, you can even run Windows on it. And so that is just a computer as any other computer. And both of them are set up so it's really easy to interact with sensors and to control actuators. So to run motors or light up LEDs or have pressure sensors come into them. What the Raspberry Pi and the Bela both have is the ability to do more complicated sound or more complicated processing of things. It can do more complicated computations, harder maths, faster, more kind of multi-threading more than one thing at a time, while an Arduino can do one thing. It could only run a lift or it could run a microwave. It would struggle to do both. What Bela then does is it takes kind of the best from both. So Bela is based off of a Linux computer just like a Raspberry Pi, a BeagleBone Black. That's what the bottom board is. So all of these are stacks of boards. So the bottom board is a BeagleBone Black. And so that's just a Linux computer. What turns a BeagleBone Black into a Bela is it has a top board called a cape, because every hardware system has to come up with some ridiculously cute little name. So Arduinos have shields, Raspberry Pis have hats, BeagleBone Blacks have capes. They're all kind of mother and daughter boards if you just want to like roll it right back to like the 80s. And so what this board does on top is it gives you audio input and output, and it gives you analog input, 8 channels of analog input, and then if it's a Bela Classic, also 8 channels of analog output. Bela Mini, it's only 8 in without those 8 analog outputs on. So kind of something had to get cut down to make it smaller. That's the thing that was cut down. Both of them are commercial products. You can very much buy them. They started as a research project here at Queen Mary, and then have was Kickstarter and now full company, and you can buy any of these things if you'd like. I think you could even part with your money and take one home today if you'd so like to, because we're in the building where all the stock is, so that would be easy. If you want to save on shipping, that could be arranged today. And
You don't work for them.
Huh?
You don't work for them.
I don't, and I don't get a cut, which is really, I think I need to talk with them about this, but I don't. No, just do research grants together, basically. So that actually brings us on to the Mini and the funny yellow board on top. So part of the research project that I'm working on with Bela is actually working with paper sensors and using paper craft and circuitry to do sensor inputs. And so if you have a Bela Mini, you have a funny experimental non-product research-based board. Some of them have a nice snazzy logo on them. This one is the first batch, so it doesn't have a snazzy logo on it. And so what this does is this will connect up to paper sensors, which I can pass around using our kind of novel, only been in existence for about 4 or 5 months version of interacting with the Bela. If you want to, you can work with the full Bela and a breadboard, and then that will be your kind of traditional wires, components kind of interaction. You're welcome to work with either and to try both out. They should look exactly the same in the browser. So your experience in the browser should not be different on either for what we're doing. But yeah, oh, I forgot. So one of the features, so the question is always, well, why don't I just use an audio shield or an audio hat on a Raspberry Pi? Why do I use that instead of this? Because this costs 2 to 3 times more than what that kind of setup would be. So part of it is we want low latency. So when we talk more about the spatial audio and head tracking, we'll really get into why we want low latency. But just in general, when we're creating interactive musical audio-based applications, the hardest test case we can think of is making something for a professional drummer. So a professional drummer has a really tight understanding of striking an object, hearing a sound, feeling, knowing that they've struck that object and the sound's coming back. And if there's too much of a delay between hitting something and hearing it, then it becomes not a playable instrument for them, certainly not at a professional level. And so if you put a computer in the middle, so you have a sensor that's being struck, a computer's coming up with the sound, and then the sound's getting played. If that computer takes too long to create that sound, that's not a playable musical instrument for a drummer. And so kind of percussion is kind of seen as kind of the hardest case. So if you have something that's a little bit more of a legato kind of maybe string, then maybe you have a bit more play and you don't need to be as responsive. And that can be down to as little as 10 to 12 milliseconds. If you have more than that time between the hitting something and the hearing it, then for percussionists, that's not a playable musical instrument for them. So Bela can get down to, in the 1 to 2 millisecond range for things. So this is much, much friendlier on having low latency things. And then, for example, if you had an Arduino that was then sending something over Bluetooth to a computer, and then you were running PD on a computer instead of being run on the same board with the sensor, you're talking about, I think, maybe a couple order of magnitude of more milliseconds of delay for that kind of system. So, and when we start talking about head tracking for binaural audio, we're going to want to keep our numbers down in the same kind of range as what a percussionist would look for. So that is the unique selling point of Bela, is the low latency audio processing. So having sensor input have the least amount of time before the sound comes out. That's what we're looking for, and that's why we're working with these. Yeah.
Can people actually hear anything under 25 milliseconds?
Everything, it depends on what it is they're listening for and what they're doing and what the situation around it is. So if it might not be conscious, they might not say, oh, I hear there's a delay there. It's saying, I can tell there's something happening. More than chance, my actions are reacting to this in a way that says that this is doing something inside my head.
Have you, is there research on that? If people really,
Yeah. Yeah, oh no, totally. I don't know, certainly Robbie would know the reference for the paper about the percussion stuff, because that's definitely his wheelhouse. I could point you on the spatial audio side, the BelaPt is the big book, so BLAUERT. It's called Spatial Hearing, and then that is a book just full of tons of studies of people listening to things like sine tones and determining how different delays between things, different angles, a lot of these kind of just noticeable difference is what a lot of this kind of general type of research is called. So a JND, a just noticeable difference, is typically figured out by having a bunch of people listen to something in audio context and then answer a question about it or do something in reaction to what they're listening to. And at what point does increasing whatever that variable is, when is that now noticeable by people? So that's then the just noticeable difference. So for kind of percussion type tasks, the literature says it's about 12 milliseconds.
Okay. Oh, well.
Yeah.
I would just know it from playing guitar. I always thought like 30 milliseconds is like.
Yeah, so there's very much, there's a wide body of literature you can look at about that. Yeah. So basically anyone inside the Augmented Musical Instruments Lab, which is not me, but definitely Robbie can point you towards people in that's a lot of their research sits inside of that kind of area. Cool. Other questions? Okay, so we are going to, I think most of you have done this already. And I think I said all this without. Yeah. So either of these boards is a computer, just without a screen, a keyboard, or anything like that. You can't connect a screen or a keyboard or anything like that directly to them. So what we do is we talk to it over a network. So these are called headless devices, if you're kind of doing DevOps world. And so we will communicate with these boards from our own computers over a USB cable. So we'll be networking over USB. It's also how the board's going to get its power. But the boards could also, if you were thinking about, well, could this go into a project I'd like to make? You can also connect a battery and have it run off of a battery. It doesn't have to be connected. Once you've programmed it, it will run that code, and you don't have to have a laptop involved. So if you wanted it in like an installation environment, you could have it so it easily just starts running your code when it gets power, and it starts running your installation or whatnot. So Bela.io is everything that is all the documentation about Bela in particular. Inside the wiki page for today, there's some particular links to some of the details of what we're working with. And everything, so Bela is completely open source, both the hardware and the software on it. So I forgot to say, it's a particular operating system. So a BeagleBone Black goes from a BeagleBone Black, or this is a Pocket Beagle, into a Bela when you add on the circuitry on top, and you also have a particular operating system image running on it as well. Those two things turn it into a Bela. So all of that, and if you want to dig into the details of all of that to make your own custom capes and things like that, that's entirely possible. Everything's open and you can poke at it. So everyone has a Bela. I think everyone's done most of this, but I'll do it as well. So who? Only one more?
Yeah, I think it's open. Sorry.
Yeah, that's true. Let me change this slide. Oh, it says it already on there, sorry. So you're going to take your, the only kind of super frustrating thing between the Bela Mini and the Bela Classic is one takes a USB Mini, the other one takes a USB Micro. And actually the Mini takes a Micro and the Classic takes a Mini. So we turn it on by plugging it in, USB on one side. So it takes, I don't know, give it like 30 seconds to start up. So actually what you'll first see as it boots up is you'll first see a USB drive appear as a mount. So you have something called BelaBoot that appears here. And so then that, you don't need anything in there, just know that exists. And then we open up a window, and we're going to go to BelaPt1.local. Let's hope I just haven't given it long enough. Yeah. Such a royal pain. There's some weird thing that's reared its head with my computer. This one was working last night. I put this one to the side. Oh, I'm so.
Try just writing in the IP address.
That's never worked.
Yeah.
Let's try that one.
R.6.2.
Yeah, it's just doing the same thing. Do we have any more of the minis?
The minis are all out.
Okay,
actually.
that's fine.
You could use a bigger.
Yeah. Those are totally fine. Those ones are quite reliable, actually. Sorry, so everyone else, if you go to bela.local, anyone else having trouble getting there, you should see a page actually load. Is that okay for everyone? Great. This is just, we haven't quite figured out what is this beautiful, unique problem with only my computer. Which is fantastic. It's not like my professional life is completely around working with Bela. So give that a minute. Excellent. So you should have something that looks like this. There we go. So this is the Bela IDE. First, let me say, if you're like, it's broken, it's frozen, I can't interact with it and change and load, a WAV file or anything like that. PD, this image that you see, is only an image. So this is not PD running in the browser. Sorry, microphone. So this is not PD running in the browser. This is a screenshot of what the patch looks like. So we don't have the ability to interactively program PD on Bela. Instead, we can run it, but we'll kind of step through that process a little bit first. So first, let's do a quick tour over what's happening here. So we have a little arrow over here, and And we have the ability to then take a look at what the code is that we're looking at. We can see settings there. We can take a look at different pins if we'd like. This is where it should be different if you're looking at a mini or a classic. It should match its image there. And then we have code examples. So this is where we're going to work from first. So the numerically inclined among you may notice that we're under 00 Soundstack. We start off at number 5, and we just left number 4 from inside of PD. So if we click on 5, it's going to load up a different image for you here, a pretty simple looking patch. Anyone having difficulties?
Yeah. I think it should be
It's
right.
running.
It's just that I came
Oh,
up
it's
with that
just-
patch to begin with.
Oh, okay.
So I was a bit like, what's going on?
That's fine. And everyone else sees this, right?